number 70. Liquid dietary supplements with fewer grams of carbohydrates are made for individuals who have diabetes. Write the formula for each of the following ionic compounds, which are ingredients in such a nutritional drink. And you're given 4 different compounds. Now, for ionic compounds, remember when you're given the name, the protocol is to put the cations first. So the metal cations come first in the name, and then you have the non-metal anions. And so looking at the names for the cations, we should be able to write what they are. And same thing for the anions. So the cations are usually pretty simple. You see magnesium. Let's do A first. So A, we have magnesium. And magnesium is an alkaline earth metal. It's in the +2 column. So that's what magnesium is. And let's just go ahead and write magnesium +2. Okay, remember the +1, +2, and then aluminum's +3. All of these other ones down here, they tend to form multiple types of charges. Okay, but here we're doing magnesium. Now, what's the anion? The anion is phosphate. Remember the 8s and the ics? The 8s and the ites, I mean. So if you see an 8 or an ite, that's telling you look for polyatomic anions. Polyatomic anions. And there's a table down here. No, that's not it. That's the metal cations. Here they are. So phosphate is a polyatomic anion of phosphorus, and there it is, PO4 -3. So PO4 -3. And now that we know what the ions are, it's straightforward to write the formula. So you're going to need 3 of the magnesium +2s and 2 of the phosphate -3s to balance out the charge. And so you got 3 of those magnesiums, and then you need 2 phosphates. So it's a group of atoms. You got to parenthesize it all. You need 2 of them. And you see that's the formula for the compound, and hopefully you can see that the total positive charge is now +6, and that balances the total negative charge of -6. Let's do B. B is, okay, magnesium phosphate. What's B? Cupric sulfate. Cupric sulfate. Cupric, that comes from the Latin name for copper. So if you go back up here, copper cations come in 2 different types of charges, like so many of these do. And there's 2 ways to name these 2 cations. You could say copper 1 and copper 2, or you can say cuprous and cupric. Us and ic, when you're talking about the cations, those are the Greek names. So I'll make a little note for that too. If you see us or ic, and it's the cation, those come from the Latin names. I'm sorry, the Latin names. And us is always the lesser charge, and ic is the greater charge. So we're dealing with cupric. So this is copper +2. Copper +2 is the metal cation this time. And let me make a little more room. Okay, and now what's the sulfate? Sulfate is, you remember, when it's the anion, the 8s and the ites, those are polyatomic anions. Okay? Those are polyatomic anions. If you see 8 or ite and it's the anion, look for the polyatomic anions and go back to that table. 8. Sulfate is SO4 minus 2. SO4 minus 2. SO4 minus 2. And it looks like they balance. You got plus 2 and minus 2, so go ahead and just write the formula together. CuSO4. Copper 2 sulfate, or cupric sulfate is the name. Okay, let's do C. C is potassium chloride. This is an easy one. Okay, potassium is one of those alkali metals. It's in the +1 column. There it is. Potassium is always +1 in an ionic compound. So K plus. And then chloride, this is how anions are normally written. Okay, it's not an 8 or an ite. Okay, it's just an ide. That's a regular anion, and those are just the regular anions. Chloride, that's Cl minus. Okay. You only have polyatomic anions when you see 8 or ite in the name. But if it's just ide, it's just one of these guys. Okay, and you can see the charges balance, so that this is very simple. KCl, potassium chloride. And then last one is calcium carbonate. You see that 8? Okay, so calcium carbonate. And let me get more room. Calcium is a normal metal cation. You don't have the us or the ic or the Roman numerals to indicate the charge. It's just a regular element name, calcium, and that's kind of cluing you in that it's just, it's not one of these guys. Calcium, there it is, Ca plus 2. And carbonate, I know that is CO3 minus 2 because I see the 8 and I'm thinking polyatomic anions, and I've seen carbonate so many times that I know it's CO3 minus 2. You see it there? Okay, that's table 3.5, and you can see these already balance, so we can just bring them together to write the formula. CaCO3.